Okay, a ball is thrown horizontally in still air from the top of a very tall building. The ball is affected by air resistance. So this is basically a projectile motion question because you have a ball thrown horizontal in still air from the top of a very tall building. However, this is a situation in which air resistance is considered and it is not neglected. The question is asking what happens to the horizontal and to the vertical components of the ball's velocity. So basically, we can actually consider this as a situation in which when you have a ball that is thrown from a very high position horizontally, so that means it will follow a projectile motion. So when you have a motion in two dimensions, so this is a very tall building, top, so for example, this is your ground. So basically, the velocity or the vector can be represented in two components. One is basically the horizontal component, and the other one it will be your vertical component. So we represent it as Vx and Vy respectively, where we can have the overall vector V as the resultant when you can solve them using Pythagoras. Now, in order to answer this question, we need to consider both of the horizontal and vertical component of the velocity. So that means we separate their components. So in order, just for the sake of discussion, I would consider both situations where one air resistance is neglected and the other one air resistance is considered, just to make a comparison. So we consider the horizontal component first, and only we will consider later the vertical component. So when we do not have any air resistance, what happens to our the horizontal component of our ball? Basically, it is just moving at a constant velocity. Why? Because there is no net force. So the net force in the horizontal component will be equals to zero. That means the acceleration will be zero, because the only force that is acting on the ball when it is in projectile motion occurs in the vertical direction. That is when, for example, here, when you have the ball falling downwards, so assuming that the downwards position is positive, then you will have gravity. So the net force would just be equals to mg, which is the gravitational force that is acting on the ball moving downwards. But what happens in the horizontal component? There's no force acting in the horizontal component. That is why the acceleration is zero. That means when acceleration is zero, that means the velocity will always be constant throughout, which obeys Newton's first law. When there is no external force, the ball will remain either at rest or at constant velocity. So these are the two cases when you have no air resistance in the horizontal component. That means VC, or sorry, the horizontal component of V will be constant, whereas for the vertical component, it will be falling with gravity. So the velocity will increase. Okay, so the velocity will increase, but the acceleration will always be gravitational constant, G. So the acceleration is constant. When the acceleration is constant, that means V will always be increasing. Now, if you consider air resistance, what we need to understand first is that when you have air resistance, that means the force. What does it mean by a resistance? It is the force that is opposing the motion. So when the ball or an object is moving forward, then the resistance will be acting backwards. That means it is opposing the forward motion. If it is going upwards, then the direction of the resistance would be moving downwards, and so on. So here, when you have the ball which is moving forward, that means you will have an opposing force Fx in the opposite direction. And when the ball is moving downwards, that means the opposing resistance would be moving upwards, Fy. So in this diagram, we can actually represent it to be, this is the the resisting force. That means it is moving upwards in the vertical components, and it is moving to the left, opposing the right motion here. So here you have Fy and Fx. So because of the occurrence of this additional Fx in our horizontal component, therefore the net force here would not be equals to 0 in this case, but in fact it will be minus fx because of the direction is opposing. Therefore, we can assume that the horizontal component of v would be decreasing up to 0. Okay, so Vx, from an initial value of Vx, it will decrease until it reaches 0, and the rate of change of this velocity would correspond to the value of Fx, which is the opposing resistive motion. So here it is not remaining constant. C and D you can just cancel out, okay, because this is considering air resistance. It will remain constant only if there is no air resistance. If there is air resistance, that means it will always be decreasing to 0. Now what happens to the vertical motion here? In this case, we know that velocity will always increase without any air resistance. However, it will increase at a decreasing rate up to a point where, because here right now the resultant force Fy will be equals to mg minus Fy, where Fy will be the resistance force, which is opposing the motion going downwards. And because we know that as the velocity increases, that means the resistance component here, Fy, will also increase up to a point where it will reach a constant value and there will be no acceleration further on. That means here it will increase, Fy will increase until to a point where, because mg is always constant, so you will reach a point where Fy equals to 0. This is what we call terminal velocity condition, where v will increase at a decreasing rate until v is constant, where you have no more acceleration, where when the resultant force is equal to 0, that means here acceleration equals 0, so that means v will be constant value. So it will increase to a constant value. So the answer is B. So it can't be increasing at a constant rate, because if it is at a constant rate, that means it has acceleration. So here we know that the acceleration will eventually become 0 because the increase in the drag or the increase of the resistive force. So that's why the answer is increase to a constant value and not at a constant rate.